Hi all, welcome to the first lecture on the course Refrigeration and Air Conditioning. I am James Matthew, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology, Kochi. When we talk about refrigeration, the first thing we remember is the fridge in our home. Can you find a fridge in the picture? Some of you also use the fridge for this purpose too, right? Actually, the fridge is one of the application of refrigeration. What is refrigeration? Refrigeration is a process of achieving and maintaining a low temperature below that of surroundings. The aim being to cool some product or space to the required temperature that is below that of the surrounding. So the device which serves this purpose is called refrigerator. A refrigerator actually works under the closure statement of the second law of TD, which states that it is impossible to construct a device which operating in a cycle will produce no effect other than the transfer of heat from a low temperature thermal reservoir to a higher temperature thermal reservoir. That means to transfer heat from a lower temperature thermal reservoir to high temperature thermal reservoir, work must be done on the system by the surroundings. So a refrigerator is a work consuming device. You might have remember how a heat engine works. The first picture shows a heat engine. It actually absorbs heat from the high temperature reservoir and convert a part of this heat to useful work, and then reject the remaining heat to the surroundings or low temperature reservoir. It works as a cyclic process. But a refrigerator, this is the refrigerator, representation of a refrigerator. A refrigerator transfer heat from low temperature thermal reservoir to higher temperature thermal reservoir by getting work from external means. So this also works as a cyclic process. So we can say that a refrigerator is a reversed heat engine. From the picture, from these two pictures, you can see that there is no difference in the cycle of operation between a refrigerator and a heat pump. This picture representing the characteristics of a heat pump. The only difference, the heat pump also transfers heat from a lower temperature thermal reservoir to a higher temperature thermal reservoir by getting by the help of external work input. So what is the difference between these two? The difference is actually is the purpose of operation. When we use this machine for cooling purpose, then it is called a refrigerating machine or a refrigerator simply. If we use this machine, the same machine is used for heating a house or a space, then it is called a heat pump. So you can see here, this is the desired output of a refrigerator. We need to cool a space or some products. So this is the purpose of using this refrigerator. But in case of heat pump, this is the purpose. We need to warm a space or house. So this is the desired output. So it is called a heat pump. This picture gives an idea about the manner of application of heat engine, heat pump and a refrigerator. A heat engine actually works above the surrounding temperatures. This chain line represents the surrounding temperature, which is denoted with the TA. So you can see from the figure, a heat engine works well above the surrounding temperature. The lower temperature may be greater than or equal to the surrounding temperature. The main difference between the refrigerator and a heat pump is in their operating temperatures. A refrigerator operates between ambient temperature, that is TA. You can see in the picture, the higher temperature reservoir, the temperature of the high thermal reservoir is greater than or equal to TA, and a lower temperature T0. So this is the temperature of the cooled space. This is the desired output of the refrigerator. But a heat pump operates between the ambient temperature. See here, the temperature of the low temperature thermal reservoir is always less than or equal to the ambient temperature, and a higher temperature Tk. This is the heated space. This is our desired output in case of a heat pump. Thus, a refrigerator that is used for cooling in summer is to be used as a heat pump for heating in winter, either by rotating the machine by 180 degree or by using some special valves. Actually, these two processes are heat exchange processes. So these heat exchangers can be, the position of these heat exchangers can be replaced by rotating the machine 180 degree, or the purposes of these heat exchangers can be changed by using special valves. We can see here 1 multiplied with 2000 lb, that is 1 ton of 1 US ton, multiplied with the latent heat of ice is 144 British thermal unit per pound in 24 hours. So divided by 24, you will get 12,000 BTU per hour or 200 BTU per minute. So as we know, 1 BTU equal to 1.055 kilojoule. So to convert this unit to SI unit, just convert this value, this 12,000 BTU per hour multiplied with 1.055, you will get 12,660 kilojoule per hour. That will be equal to 211 kilojoule per minute. That is equal to 3.5167 kilowatt. So 1 ton of refrigeration is equivalent to the 3.5167 kilowatt or kilojoule per second. The broad way of classification of refrigeration is natural refrigeration and artificial refrigeration. In natural refrigeration, we rely on nature for providing refrigeration effect. In olden days, refrigeration was achieved by the use of ice or evaporative cooling. The ice refrigeration is achieved by transporting the ice from colder regions, or the ice is harvested in winter from the colder region and stored in ice houses for summer use. The last method for producing ice is nocturnal cooling. The principle of nocturnal cooling is nothing but just leave a shallow pool of water in night sky. We know that the stratosphere is basically at a temperature of minus 55 degrees Celsius. So if the sky is clear, the water can lose heat by radiation to the stratosphere. So this is the method used for producing ice in India for centuries. The other method of natural refrigeration is evaporative cooling. It is the process of reducing the temperature of a system by evaporation of water, because the evaporation process is an endothermic process. So you will get a low temperature. Evaporative cooling has been used in India for centuries, even now, to obtain cold water in summer by storing the water in earthen pots or vessels. The water permeates through the pores of earthen vessel to its outer surface, where it evaporates to the surrounding, absorbing its latent heat in part from the vessel, which cools the water. The other natural method of refrigeration is cooling by salt solutions. Certain substances such as common salt, when added to water, dissolve in water and absorb its heat of solution from water, because it is an endothermic process. This dissolving process is an endothermic process. So it absorbs heat from the water. So this reduces the temperature of the solution, that is water salt solution. Some of this type of salts are sodium chloride salt, NaCl, can yield temperatures up to minus 20 degrees Celsius, and calcium chloride up to minus 50 degrees Celsius in properly insulated containers. But this method is very rarely used, because we should apply heat to separate this salt from the water. The major limitations of natural refrigeration methods are it depends on local conditions, uncertainty due to dependence of weather, and the difficulty to produce large amount of refrigeration effect. Because of these limitations, people are trying to produce refrigeration artificially. So these are the main methods of artificial refrigeration: the gas cycle refrigeration, vapor compression refrigeration, VCRS, vapor absorption refrigeration, VARS, steam jet refrigeration, thermoelectric refrigeration systems, and vortex tube refrigeration systems. We will discuss all these methods in various modules of this course. The first module includes the gas cycle refrigeration, which we will discuss in the next part of this lecture. Some of the major applications of refrigeration are food processing and preservation. Chemical and process industries need refrigeration, and also the comfort and industrial air conditioning. All these are the major applications of refrigeration. Which of the following can be called as a refrigeration process? Cooling of hot ingot from 1000 degrees Celsius to room temperature, cooling of a pot of water by mixing it with a large block of ice, cooling of human beings using a ceiling fan, cooling of hot water by mixing it with tap water, cooling of water by creating vacuum over it, and cooling of a hot cup of coffee by leaving it on the table. So just remember the definition of refrigeration we discussed in the beginning of this lecture. The refrigeration is a process of achieving and maintaining a low temperature below that of surroundings. Just keep this definition in mind and try to find the answers of this question. Thank you.